Okay, good afternoon, everyone. How is everybody? Thank you for tuning in. My name is Marcus Weisgerber. I'm the Global Business Editor at Defense One, and we are with you today to talk about new orbit, space, and an all-domain future underwritten by SAIC. Today, we're going to discuss how various domain puzzle pieces, including the newest space piece, fit into the larger picture of joint air domain command and control. And before we get started, I have a few housekeeping items to tell everybody about. At the bottom of the WebEx platform, you're going to see several icons, including Q&A. That's how you can ask questions of our panelists. So please feel free to drop them in there throughout the conversation. And I will try to sprinkle them in throughout our discussion at the beginning, and then we'll try to get to the rest toward the end. So also, I want to let everyone know I'm filling in for my colleague Patrick Tucker, who is supposed to be doing this. Patrick is alive and well, but he had something pop up, and he sends his regrets for not being here today. Joining me today, though, is Dr. Mark Lewis, somebody I got to know a long time ago when he was Chief Scientist of the Air Force, and he is, I guess, at this point become a regular on Defense One's virtual events. He is the acting Deputy Undersecretary of Defense for Research and Engineering at Pentagon. Dr. Lewis, thank you for joining us. And Dr. Ellie Nywood, who is Vice President of Intelligence Programs and Cross-Cutting Capability at MITRE. So thank you for the two of you gentlemen for joining us today. I figure we could start with just Dr. Lewis with you with just kind of a big picture question and kind of just at the strategic level. We often hear JADC2 talked about all the time. Can you talk about the department's vision for how the space layer will play a role in JADC2?
So actually, if I could, let me make it even larger than that. All right. First of all, let me start off by thanking you for the opportunity to be here today, and it's especially a pleasure and honor to be on a panel with my friend Ellie Nywood. Ellie and I have worked together since we were graduate students together for more decades than either one of us are willing to admit. But so it's I really appreciate you setting up this opportunity. So of course, we think in terms of a series of modernization priorities within the department. Right now in R&D, we've got 11 modernization priorities. But they're not standalone stovepipe priorities. They interact with each other. And so two that interact very, very closely are our efforts across the board in space, but also our efforts in fully network command control communication, FNC-cube, of which JADC2 is an important element, not the sole element, but an important element. So building on that vision for FNC-cube, we really have three pieces to our architecture, right? There's a hardware piece to it, there's a network piece to it, and then there's the application piece to it. And space plays into all three of those elements. All right, obviously it's got a hardware piece to it, but it's also in the networking and how we connect our various pieces in space together to the ground, to each other, and making sure that those are all aligned with the various other activities that are going around, around the department. We want to make sure all the services are aligned, all the agencies are aligned. To that end, we've got our Space Development Agency, one of our key players in the Office of the Undersecretary of Defense for Research and Engineering. They put forward this vision for future space architecture that includes our transport layer, includes our tracking layer, but more importantly, has an emphasis on resilience. And that's really, if I were to capture it, that's what we're after. We're after resilience as we assemble these future networks, not just resilience in the hardware, but also resilience in how they network, also resilience in the way they interact, and even in the applications layer.
Great. So Ellie, maybe you could talk to us a little bit about MITRE's been. I was reading through a report last night as I was prepping for this panel that MITRE's done on JADC2. Kind of maybe talk to us a little bit about what MITRE's been doing recently with JADC2 and some of the recommendations it's been making.
All the things that Mark talked about, we think are great. Having that, hardware that can contribute, having that resilient communications, the role space will play. But the other thing that I think we see as lacking to some extent is, what is the different and advanced, or new version of command and control that we need to have to make JADC2 happen. How do you do situational awareness? How do you do decision making differently, bringing capabilities from all these different domains and different services together? And so from a MITRE perspective, we see I'd say we don't see the level of attention to that. We don't see the vision there that we'd like to see. We see pieces of that in R&E coming out of FNC3. We see pieces of that coming out of the space community, pieces coming from the Air Force and ABMS, pieces coming from the Army and Project Convergence. But how does all of that come together, and who will take responsibility for that and make sure that it all works together at the end of the day to give combatant commanders, the kinds of capability they're looking for and needing? And so MITRE is working hard to try and bring those different pieces together. We're involved in almost every one of them. Can we supply some of that glue? Can we supply some of that vision to bring those pieces together in sort of new and exciting ways that will allow us to really address the peer threats that I think JADC2 is really meant to help us with?
So Dr. Lewis, let me pivot back to you for a second.
Yeah.
So how do you, what Ellie was just talking about, there's a lot going on within all the services. I think, a few years ago when I guess General Goldfein really started beating the drum on this, and the need for this, there were kind of skeptics because it wasn't, a big sexy fighter jet or something really, tangible. But it does seem that over the last 3-4 years, there has been a lot of buy-in and across not just the leadership but throughout the services. But as Ellie just mentioned, it's kind of you have some fragmented initiatives, if you will. How do you bring those all together? Do we need like a person? Does it need to be like a JADC2 czar or something like that?
Well, so I would argue that's part of what our job is in R&E. All right, what do we do? So at the end of the day, the services obviously organize, train, and equip. In OSD, we try to coordinate. We try to make sure that we're identifying gaps. We're also looking for overlap, but also making sure that everyone is on the same page. That we that we talk about fully network command control communication. That we that requires that everyone be able to interact with everyone else, or else it's not fully networked. I'd actually say I think we've got that, czar. So within R&E, each one of our modernization priorities has a principal director who we designate as the lead in that subject area. I actually call them czars. We played with the idea of giving them the official title of czar, but we didn't think we'd succeed in that one. But within our own circles, we sometimes refer them colloquially as our czar. And in our case, for FNCQ, our lead is Dr. Michael Zatman. And part of what he has done is work with the services to make sure that they're coordinated. I will tell you, so I've been back in the building now since early November of 2019. And when I first walked in, I didn't see as much cooperation and collaboration between the services as one would have hoped for. And now I would say it's actually in pretty good shape. The Air Force and the Army especially get very high marks. The Navy is also coming up to speed very, very quickly. So we're moving in the right direction. I agree completely with everything that Ellie said, but I think we're making significant progress. Exactly in the areas that he said we need to be making progress.
So Ellie, in the report that MITRE put out, you talk about the need for experimentation. Can you talk a little bit about about what type of experimentation you want to see, and then maybe Dr. Lewis, can you follow up and talk about kind of I know I see press releases and stuff from time to time about services doing stuff. Can you talk about a little bit about what the services are doing in this area, and then more broadly plans for, I guess, more joint experimentation?
Yeah, so I think, a couple things. I think, as you see in the press, there's, I think, a lot of exciting experimentation going on. There's the ABMS on-ramps, that you see quite a bit about. Again, Project Convergence, has a big demo going on, I think, essentially as we speak. There are also efforts going on out at some of the combatant commands to try and apply, various technologies and various prototypes that have been developed, some connected to ABMS, some connected to Project Convergence, others more standalone. I think so I think that's all good, and there's a lot of good lessons learned coming out of those. I think two things that we would like to see more of. One is, those, demos, fairly expensive, fairly limited in terms of, what you can bring to a demo. You can't run many different cases. We'd like to see them really building on, modeling in sim and smaller scale experimentation so that you're sort of filtering out what is it that really works, what doesn't, and sort of bring the best of that, I think, to these more intensive demos. I think the other thing that's lacking to some extent is how are all of these building to some larger, greater capability over time? Is there progress from one demo, one experiment to the next that is leading towards this larger scale vision? And I think part of that's challenging because I don't think that larger scale vision exists. Again, I think within FNC3, great ideas about the resilient comm piece and the robust networking. In terms of what situational awareness looks like, in terms of what decision making looks like for the future, I think we have less there to point towards yet. And so I think, still more that needs to be done to drive where we're going, and then use the experimentation to really help get us there, help show what's working, help change and iterate on that vision based on what you learn from the experiments.
Dr. Lewis, can you talk to us a little bit about what, from the DoD side of what experimentation and what you have planned?
Yeah, so, as Ellie just pointed out, so a number of the experiments have actually been very, very joint. Look at ABMS, for example. It was very much a joint activity, not just a single service involved, but also agencies supporting as well. I guess the one thing I would disagree with is we are, in fact, developing, a very significant roadmap in FNCQ. And it's a very detailed roadmap. It includes, timelines and metrics and dollars spent, includes off-ramps, indicators of success. So our job now is to get the services to execute along that roadmap. And again, it's an area where we're actually seeing a lot of progress. It's the way the Pentagon works. We're not very effective when we in OSD on the third floor tell the services what they should do. It's a dialogue. And in fact, this is an area that we work very, very closely with our service partners. We've together formulated paths forward. We've gotten a certain amount of buy-in. There are parts of the roadmap that we need to focus a little bit more attention on. But by and large, we've got that vision. We're at the point now where we want to execute.
So a reminder, if you have questions for us, please feel free to submit them in the chat box on the screen. And if you see me looking away over here, that's because my screen is down here to my left. It's not that I'm not paying attention to everybody else on the line. Last week, Air Force Secretary Barbara Barrett announced this effort to showcase weapons that are designed digitally, this so-called E-series, and giving everything from planes to satellites an E designator, a lowercase E designator, before its name, if it's digitally engineered. And Dr. Roper, the head of Air Force Acquisition, he mentioned that actually some satellites are being developed this way already as we speak. And then, we know this technology is being used and has been being used throughout different parts of the industry for a while. So, Dr. Lewis, maybe for you, can you talk about digital engineering and how that's underpinning DoD's ability to adopt JADC2?
Sure. Look, digital engineering is, I think, it's clearly becoming instrumental in the way we're going to do everything in the future, right? It gives us new capabilities. We've already shown incredible efficiencies that we can realize through digital engineering. It also gives us other abilities. So we can do thought experiments. We can do with modeling and simulation, modifications, trades. We can even look at future derivatives of systems much more efficiently, much more effectively. So I think the very simple reality is it will be a part of almost every major system that we develop. That'll be air, that'll be space, it'll be manned, it'll be unmanned. Now, of course, we're still learning. So we're still seeing where digital engineering works best. We're seeing examples of things that we need to improve in this area. It's a work in progress. But overall, it's almost, I would say it's almost a given now how we're proceeding into the future.
Mm-hmm. Is SDA, like I said, Roper talks about the Air Force doing some other, and I guess by default now the Space Force doing this. Is SDA, looking to leverage whatever's happening there in terms of looking at this Leo constellation that'll play a role in JADC2?
Yes. So, the reason we created SDA was to essentially create an organization with a new way of doing space, right? A fast, innovative approach, leveraging commercial capabilities. SDA just released its first tranche of satellites. We did the announcement a couple weeks ago. That was absolutely amazing. We went from an industry day in late spring to an announcement, first contract announcement by the late summer in absolutely record time. So yes, SDA is leveraging all those tools. It's how we view the future for space.
And I apologize for not attributing that question because Courtney Alban from Inside Defense sent that one to me in advance, and she was on another call right now. So I wanted to make sure I gave her credit for asking that one. And again, reminder: if you have questions, I see them starting to come in.
Yeah.
Please put them in the chat box. For both of you, I guess, is there any? And I saw this in a CRS report, as the background issues, JADC2 background issues for Congress. Is there any type of cost estimate for what this, seemingly gargantuan initiative will ultimately cost taxpayers?
So I've seen numbers of sort of all the programs that are, contributing or part of JADC2. Those numbers are, gargantuan. But I would say, I think to me what's very interesting is, relative to other things the Defense Department does, command and control, cheaper, than buying a new bomb or, buying a new missile in a lot of ways. It's about how do you build the interfaces. It's about how do you have, ways to make things interoperable. It's about displays for situational awareness. Again, on a personal scale, these things are very expensive.
Yeah.
But on a DoD scale, I think what you're really doing is leveraging capability you've invested huge amounts of money in much more effectively with a relatively small percentage of the dollars that went into the hardware and the large systems themselves. So I think JADC2 is an enabler that is cheap for the capability you're buying with it.
Yeah, I agree. It's actually very difficult to try to capture a dollar figure for this for the reasons that Ellie just mentioned. It's part of what we're doing. I don't know how to completely separate it.
So how about this? I'm not a super network guy, but I understand again the big framework of this. So obviously you're not going to throw away every type of weapon that you have, but you could put. I would imagine putting constellations in space might be actually easier than modifying or coming up with gateways or modems or whatever to connect all these. Can you maybe both of you talk about just the kind of that aspect of modifying existing weapons so that they could, an F-35 to, an AMRAAM missile to, a Stryker vehicle on the ground?
So I guess I'd say, you're kind of asking a classic engineering question, which is, when do you stop investing in improving the legacy thing you've got and make the investment in the new thing? And that's almost what we wrestle with on a daily basis across the board, across a range of technologies. We're pushing modernization priorities. Inherent to that is the idea of embracing new technologies or new applications of technologies. And we're competing with all legacy systems that in some cases are effective, that we've made big investments in, that we have experience and expertise. So it's almost on a case-by-case basis. I will tell you there tends to be a bias across the board to continuing with the legacy systems. And one of the themes that we've been trying to carry through the department is to move away from that and say, all right, at some point we have to give up on the legacy and we have to move to new ways of doing things. There might be a higher upfront cost. We think in the end, the overall lifetime costs will be much favorable. But it's almost on a case by case basis, weapon by weapon, system by system, application by application.
Yeah. So I would differentiate a little bit. I think, certainly as Mark points out, I think there's, every case you need to look at when is it time to reinvest and, redo that weapon system or buy something new. I would say from a JADC2 perspective, though, we do think one of the challenges, how do you tie all the things that you have into that JADC2 system?
Right.
And I think if it's done right, I don't need the AMRAAM missile to be linked, to the AOC or the multi-domain operations center to do JADC2. And so the information that you need to move back and forth, I'll say at an operational level to enable, all domain and joint command and control is much more limited. And we believe that you can tie, almost all your existing systems in some way to doing that. If you're careful about what information you need to move, how you need to move it, who needs to see it, and who needs to talk to who to get the benefits of JADC2.
Right. Exactly, and remember also you can do things in a stepwise fashion. I mean, step one might be, you've got component A talking to component B through a translation node, and the next step is component A talks directly to component B.
Yeah.
One of the, I would say probably the most consistent themes, even perhaps bridging the Obama administration and Trump administration has been this desire for the Pentagon and for everyone to move much faster.
Yep.
Can you talk? So again, it's taken us a little bit of time to get to where we are now. How far are we from actually being able to use this type of technology and or in some sort of form on the battlefield?
So Ellie, you want to take that? Or?
Yeah, I'll start. I mean, I think, I think a couple things. Again, I don't think of JADC2 as a technology. I think of JADC2 as an operational construct that you have technology that is a significant contributor to, right? So can you use AI for decision making, in new ways? That's a technology. Can you bring the services and the domains together, and so you're making decisions across them in some more optimal way? It's probably not a technology. It's probably TTP. It's probably ConOps. So I don't think we're that far away from being able to do that. I'm not sure how much closer we are than we were 2 or 3 years ago. I worry about that a little bit more. I think if we got after this, seriously, we could within a year be doing, some of the things that JADC2 is all about. With as Mark said, it's a stepwise process. We won't have all of it and all the capability. Not everything will be shared with everyone who needs in a year, but we could start operating more in this way relatively quickly.
Yeah, I agree. And I think, to me, I would describe it not as when can we do it so much as how do we scale it up, right? So we've already got local examples, and we've already got local pockets. Our job now is to scale it up, make it more broadly available.
So that's a good lead in, Dr. Lewis. So what right now what is your, I guess, your biggest challenge to doing that? Is it policy? Is it technology? Is it getting the money?
Oh well, money is always the biggest challenge, and but it's not really a technology challenge. I think we know how to do the technology. Ellie made that point very effectively. It's not even really a policy challenge per se, in the sense that everyone kind of agrees this is the right thing that we have to do. It's obviously it's the obvious direction we need to move in. I'd even say it honestly, although I gave you a slightly glib initial answer, it's not even the money so much. It's really the coordination and the will. So the Department of Defense is a very complex organization. A lot of stakeholders, lot of players, and in getting those aligned is sometimes more of an art than a science. But again, I think we're actually making pretty good progress.
Ellie, how about you? What do you think the biggest challenge is?
Yeah, so I mean, maybe similar to what Mark said. I would say leadership. Who is making this happen? Who can drive where the services go? There's a CFT and the joint staff, which owns a piece of this. As Mark mentioned, there's the FNC3 piece of this. which I see as a critical enabler, but maybe not there all the way. The combatant commands need to have a say, need to be driving what we're doing, and we don't see who's doing that. They've talked about parceling pieces of it up to the Air Force, a piece to the Air Force, a piece to the Army. It's not yet coming together. There's no one I see with, sort of the vision and the authority to make what needs to happen. Again, across not just the technology pieces, but the technology and the ConOps and the operating structures and the experimentation campaigns and all of that coming together.
So we have a question on the from Rachel Cohen at Air Force Magazine, and she said, for Dr. Lewis, it's for you. She asked if you think any of the new OSD level tech initiatives will come out of the Joint Staff's JADC2 strategy that's due out in December, and again, which we've touched on already, but more of when do you think we'll actually see true JADC2 operations?
I'm not sure I would speculate on that.
Okay. Ellie, did I interrupt you? Or?
Yeah.
Yep.
Okay. Just right now, in terms of space and just in terms of industry, we're seeing, a lot of this relies, I would believe, on new space, and new space has been with coronavirus has actually, had been probably one of the I know key areas that I constantly hear from in the acquisition officials at the Pentagon that they're very worried about.
Right.
It has it is and potential for companies to actually go out of business. Dr. Lewis, is there anything? One, is that a concern? Is that a concern for you? And two, are there any initiatives, efforts? I know, and again, in acquisition, we're seeing money flow faster to contractors right now. Are there any initiatives, new space-wise, tied to JADC2 that are maybe being fast-tracked or pushed forward quicker than?
I'd actually say across the board. So, especially when the pandemic hit and the resulting aftermath, we had an effort led by our colleagues in A&S, but R&E has been supporting, looking across the industrial base, not just the top tier suppliers, but looking right down the industrial base to the tier 2, tier 3 specialized shops, and we've been doing a deep dive, trying to identify companies that are at risk. Sometimes you'd find unique supplier, some of a very small operation, but sole supplier of a particular component. So we have been monitoring that. There's another element of that, which is we've been looking for vulnerabilities. We want to make sure that no peer competitor tries to take advantage in this time and try to acquire a capability that we will ultimately need. So yes, we're watching this. We're concerned about it. This is a kind of a critical time for the commercial space industry. But with our friends in A&S, we're paying a lot of attention to it.
And a follow-up question we got from Aaron Mehta at Defense News, which is not necessarily tied totally to JADC2, but building on the industry right now. He said on Monday, General Hyten, Vice Chairman of the Joint Chiefs, was talking at an event, and he was asked about how to make life easier for new entrants and new technologies, and he indicated that the department has not done a good enough job of having R&E be the lead agency for technology development. Many companies just have no idea who to talk to, given the different centers around the Pentagon, when the whole point of R&E was to be the single point of contact.
Yeah.
One, do you agree with the assessment? And then two, I guess how can R&E do a better job of reaching out to smaller companies?
So I've learned never disagree with John Hyten. He's always right. But look, why was R&E set up? It was set up for many reasons, but one was just for that, to be the kind of the touch point for industry, an entry point into the Pentagon. To that end, we work very hard at doing just that. We have a number of different components in R&E that are access points for industry. DIU, I think General Hyten was speaking at a DIU event. We're celebrating the 5th anniversary of DIU right now, Defense Innovation Unit.
5 already, wow.
I know, 5 years, it goes by quickly. But, you look at what they've done in rapid contracting and bringing in new contractors, the non-traditional contractors. They've done things like, for example, they've brought in parts of the UAV industry that were just not available to us previously, and so that's been tremendous success. Remember, DARPA is part of R&E, and of course industry knows DARPA goes to DARPA, and we've worked very hard to kind of shore up the ties. The joke was that in the past DARPA kind of worked for R&E or 18L, but it's always kind of had this independent streak, which it needs. But we're doing a really good job now, I think, of aligning the DARPA priorities with our overall department priorities, our modernization priorities. Remember also, we've got programs like SBIR. So we do SBIR and STTR. And we're expanding the number of events that we do. I think next week we're doing an SBIR event. We've got over 1,000 companies that have already signed on to participate. I know about it. I get to do the keynote for that one. And again, one of the things that we're trying to carry through in order to give industry the kind of demand signal, say, look, we in the department have come up with our modernization priorities. They're not the only thing that we're doing. They're roughly about 20% of our RDT&E portfolio. But those modernization priorities kind of point in the direction of where we want to go in the future. And so we're telling industry now, hey, we'd love for you to come in and tell us what you would do in those areas. And here are the mechanisms, including SBIRs, STTRs, DARPA seedlings, all these opportunities for them to come reach out to us. I'll also say we have very much an open door policy. So I have a pretty steady stream of colleagues from industry coming through, presenting to me, presenting to my colleagues on what they're doing. We want to be the recipient of fresh ideas, new ideas, and make ourselves available.
All right, great. We have a lot of questions that have actually come in, so we'll shift to them as we have about 10 minutes left. First one says, how are you testing quantum communication sensors and networking and relating to the members, entrepreneurs, large and small corporations, national labs, academia of the Quantum Economic Development Consortium?
Great. So we have a very robust program in quantum science. It's led by our principal director, Dr. Paul Lapata. Paul is absolutely brilliant. He's leading the department, developing this roadmap for quantum. So let me tell you the biggest challenge we have in quantum. There are tremendous opportunities in quantum, but the biggest challenge is it's an area where there is a lot of hype. The signal-to-noise ratio on quantum, I would rate, is relatively low compared to some of our modernization areas. There are some amazing things that we can do with quantum science, and we look into the future. Position, navigation, and timing, for example, quantum sensors. We think that there's tremendous payoff there. Then there are some things that we kind of, at least in the department, we kind of scratch our head and say, okay, maybe there's a pony there, maybe not, but it's not where we want to put all our investments. Quantum communication, I'm gonna confess that there are elements of quantum communication that we are open-minded but skeptical on. And things like quantum computing, great promise for the future, but we see that as very, very far off in the distance. But the great part about that is if you think from a whole government standpoint, we've got other organizations, including non-DoD organizations, that are investing in quantum and are making some of those longer-term investments that then we in the DoD would hope to leverage at some point.
Marcus, are you muted?
Yes, I think we lost you.
There we go. They unmuted me.
Okay.
This is like event 50, and it's the first time I did that, so I will own it. And I thank whoever unmuted me on the other end. So here we have another question. It says, I find that MDO, JADO, JADC2, they're often used interchangeably, as if they were the result of a simple rebranding exercise. However, my sense is that they are distinct. Can you please highlight some of those distinctions?
Yeah, I could start with that one.
Yeah, Ellie, you can take that one.
Go for it, Ellie.
So I think certainly we see a big difference between operations and command and control, right? So MDC2 or JADC2 is the decision making. It's the situational awareness that you are using to decide how you use capabilities within either MDO or JADO, right? So the command and control enables the operations. So I think those are fairly distinct. I think the shift from MDC2 to JADC2, I think it was more than just rebranding. I think it really was a push that I can do multi-domain command and control within the Air Force by bringing air and space and cyber together. I can do multi-domain command and control within, say the Navy by bringing air and maritime together. I think what what really the Joint Staff and the JROC were pushing for when they moved to JADC2 was make it about all domains and make it about the services coming together. And so I think that is it's partly just the semantics, but I think it was a push to make it more universal like that, which I think is important.
Yeah. You're muted again.
There we go. Sorry. Because I'm trying to read the little chat window, right?
I was going to see if this was a game of guess the question, but okay.
Read your lips.
Yeah, exactly.
Go, yeah. So what will be the relation between the multi-domain task force and space assets? I suspect this is who will coordinate. I guess who will coordinate the space agency with the operational level commander, and how will space? It must be who will get space. Yeah.
Maybe, I understand that question.
Yeah. Maybe.
Yeah. So I'll say that I think there are some critical, lines to be drawn in terms of interaction between, space and, in JADC2 and all domain command and control. And I think, I think the Space Force is still, wrestling with what that role is to some extent. But I would differentiate between, doing command and control for the space fight and leveraging space capabilities to contribute to other aspects of the fight. And so, I think, that is, to me, a part of that relationship. The multi-domain task force needs to be able to draw on space capabilities. It could be commercial. You talked about new space. How are we getting a commercial space company to look at a location and take an image for us? It would be the multi-domain task force. I think that would be driving that. In terms of executing that fight in space and, doing command and control to protect our space assets, that might be coming from the Space Force or from STRATCOM or from, Space Command. And so I think there is that difference between using space capabilities and doing command and control within space. And so I think that's a, relationship that needs to be defined better over time, but I think we're getting there slowly.
So here's one that's a little simpler. How well do you think Space Command and Control is integrating with JADC2, and what is the process?
So I would say, we're not there yet. I think they are working to do that. Again, I think some of the ABMS on-ramps have started to bring, space capabilities in to the larger JADC2. I mean, I think there's a critical dependence. A lot of JADC2 today, to date, I'll say, is about sort of long-range fires and precision fires, and people are relying on space capabilities to be part of the sensing layer for that. And so there's definitely connectivity there, and there's been testing and there's been demonstrations that show you being able to leverage some of that kind of capability. So I think that's going well. I think the larger set of how do you bring all the things going on in space to bear on JADC2, still work to be done, but I think we are slowly starting to get after that.
Right.
So we have one from Dr. Groves at National Defense University. He writes, the DIB has evolved to a few prime integrators aligned to major platforms. JADC2 disrupts the platform-centric DIB structure, suggesting need for an uber prime integrator to tie it all together. How does DoD incentivize the DIB, Defense Industrial Base, to move that way?
Not the Defense Innovation Board. Yeah. Battling acronyms.
Yeah. So I would argue, I think JADC2 could actually help us move in the opposite direction.
Yeah.
Right? That, if you define the interfaces appropriately and you don't force, tight coupling and complete interoperability, JADC2 could allow, smaller players to play, significant roles. If the government owns that overall architecture and framework, now a lot of people can come in and sort of plug and play. I have a better algorithm for doing decision making. I should be able to pop that right into your JADC2 framework and make it happen. And I think, for example, the ABMS effort has, I think, done a really nice job of reaching out to a whole new set of, pioneers. They talk about things like that, who can bring new capabilities to bear from smaller companies. So I think JADC2 could actually help us bring more of the industrial base to bear on some critical problems.
Yeah, I agree completely. I think the question is actually, I would disagree with the basic thesis of the question. I think we're moving the direction. If we establish the standards, then it opens up to many more players. It's almost the USB port model, right? If I've got the USB plug, I plug into the port. I know I'm going to work as long as I meet the right standards.
Has there been resistance, Dr. Lewis, like from industry? I mean, we hear this from. I know Dr. Roper talks about this all the time with sustainment and kind of the wanting to do the same thing just with weapon sustainment there to the term he uses, vendor lock.
Yeah.
Has there been resistance here?
Actually, not a lot that I've encountered. Our partners in industry have been very supportive, and that's across the board. We've gotten very, very little pushback. I think what we've seen, our friends in industry are looking for our demand signal, and so that's kind of what that's kind of our responsibility. Our responsibility to work with industry to kind of offer that demand signal for them to build on.
All right. Well, it turns out that's probably a great place to wrap it up as we've hit our time. And at this time, I'd like to thank Dr. Lewis and Dr. Nywood for joining us today. And I would like to turn the program over to Daniela Fayer, Defense One's publisher, and Jim Light, Senior Director of Space Strategy for SAIC's National Security Group. Thanks for joining us today.
Thanks so much.
Well, hello, everyone. I'm Daniela Fayer. I'm the publisher at Defense One, and I'm excited to continue today's conversation with Jim Light. He's the Senior Director, Space Strategy, National Security Group at SAIC. Welcome, Jim. Thanks for joining me today.
Thanks. Pleased to be here.
Jim, I'm broadcasting from Arlington, Virginia. How about you? Where are you?
Redondo Beach, California.
Wow, I am jealous for a lot of reasons. It's a privilege to talk to you today. I spent a little bit of time reading your bio. You have a distinguished career of service with the Air Force, NASA, and other government entities on both sides of defense industry and government. I'm anxious to share with our audience your perspective, but before we get started, would you just to set the stage for them in your own words, just tell us a little bit about yourself, how your career has evolved and your journey to your current position and role with SAIC.
Okay. Well, pleased to be here. Appreciate the opportunity. My whole space career started out when I'm going to date myself, about 9 years old, watching Neil Armstrong walk on the moon. And from there, I knew I wanted to have a career in space. My guidance counselor said, go get an engineering degree and go in the Air Force. So that's what I did. Aerospace engineering degree, went into the Air Force, and just by luck, I got to work with NASA on the space shuttle program for my first 6 years in the Air Force, and grew up to be from a systems engineer to a project engineer for both Challenger and Discovery. And that was a unique time in my life. Lots of hours, lots of learning, and lots of excitement working, a critical program. And also get to understand what launch is like, what on orbit, the challenges of on orbit activities are. And then rare at that time was reentry and recovery. So it was really foundational to the rest of my career. The rest of my career in the Air Force, I went through different groups, all related to space. DoD satellites. I got in the intelligence community working launch and communications and satellites. And then when they offered the early out, at the end of the Cold War, I had some opportunities with industry, and so I took them and jumped out of the Air Force and started a great career. Started as program manager and systems engineer and worked my way up to VP in a couple different companies, working everything from commercial space to NASA programs to intelligence communities programs to Air Force programs. So it's been a fun career. When SAIC bought SAIC, they contacted me. I was in another company. They contacted me and he asked if I would help integrate SAIC's capabilities with SiteDoors. And so I jumped at that opportunity, and it's been a fun, going on 5 years now, been fun time at SAIC.
And today we're starting our first installment of this new series we're calling Space and an All-Domain Future. So, as we're learning from conversations this week and in coverage on my brand, Defense One, as well as NextGov and other media outlets, we're all talking about Joint All-Domain Command and Control, or JADC2 as a concept, and how it's going to play an integral role in the future of the Defense Department's mission. And so in today's discussion, I wanted to ask you, given your background, about your perspective on JADC2, the role the new Space Force will play, and SAIC's approach in supporting all the efforts around it. So let me start by asking you, what do you think are some of the greatest challenges facing DoD and specifically the space community? And with SAIC's long history of serving government, how is your organization uniquely positioned to help address these challenges and serve the overall mission?
Okay, yeah. From a space warfighting domain perspective, I think we can bundle the challenges into two main buckets. The first is, space is now a contested domain. And the second is that there's new warfighting systems that our adversaries are deploying that require space capabilities to help work. So those are the two main areas. The U.S. has enjoyed the best space systems in the world supporting our warfighters, and that has not gone unnoticed by our adversaries. And so now space has become this contested domain. And so our challenge is to quickly evolve what we've got on orbit into a resilient enterprise that can continue to support our warfighters ahead of the threat, and now also fight the battle in space to keep our systems safe. So while we're doing that in parallel, we also have to enhance those current space systems to meet the challenges of the new weapon systems like the hypersonic vehicle that some of our adversaries are trying to deploy. And in parallel with that, there's an evolving C2 issue, which gets into JADC2, which we'll talk about a little bit later. But SAIC is very proud of the key role we're playing in that movement from space as a benign domain to space as a contested domain. We've been working deeply with our current customers on evolving the individual space systems into a resilient enterprise. And at the same time, while we're doing that, we're helping some specific segments of our customers define and develop the new capabilities to detect and thwart some of the new adversarial capabilities. To achieve all of that, you have to get more integrated in command and control. We've been helping architect the new command and control systems on the space side as well as on the rest of the warfighter domains. And what we saw early on is, this new paradigm that we're having to face with these highly integrated systems required a new way of doing systems engineering. And so SAIC has been investing in digital engineering and applying it to our programs for our customers to help facilitate this move into the new paradigm.
I'm fascinated by that terminology, digital engineering, and I'm glad you mentioned it. As the DoD looks to increase its space presence, and I assume to achieve dominance in that realm, can you elaborate a little bit and discuss the role of digital engineering, just sort of like definitionally, and then just expand on that?
Yeah, sure. So we're transitioning, as I said before, from kind of stovepipe systems into these systems that have to be tightly integrated and interoperable to be effective against the growing threat. So that complexity is combined with the need to move rapidly because our enemies are moving rapidly. And you put that together, it means we can no longer rely on our current systems engineering processes, which are largely dependent, on individual systems engineers entering data into an Excel spreadsheet, a Word document, or a database that very few people have access to. Digital engineering allows that same engineer to enter their data once, and it's accessible to the whole enterprise, and it gets built upon rather than pigeonholed into a server or a laptop. And the promise of digital engineering also enables us to automate systems engineering processes that formerly we did, very manually and via meetings and stuff like that. So there's that promise out of digital engineering. As you start employing digital engineering and you apply other tools like modeling and sim tools or mission engineering tools, you can facilitate a lot more rapid strategic decision making by the customers, as well as doing verification and validations of systems much quicker than we used to be able to do in the past. And so what that means is we can deliver systems for millions less than we were able to in the past. But more importantly, we can deliver them faster to get them to the warfighter faster and hopefully ahead of the speed of the threat that's evolving. Then as systems mature, you keep feeding the digital engineering system, you start developing a digital twin. And that digital twin can be used by the space warfighters to start playing with the system, training on it, and experimenting with it before it's ever deployed. And that way, when it is finally turned over to the operator for operations, they can employ it to best effect. And then once on orbit, the system can, the digital engineering twin, digital twin enables you to look at your systems on orbit and compare to the digital twin to see if there's deltas between them. Do you have anomalies on orbit? Are you being attacked? Or is your system nominal? It also allows you to do system planning. So digital twin means a lot to the space operator. And then finally, the last real benefit of digital engineering is as you turn these over for sustainment and maintenance on the systems, they keep a common technical baseline that is current and up to date, which is a problem we have today with paper systems and stovepipe systems. So that's a lot of words, but digital engineering is absolutely essential to getting to where we need to face the threat of the future.
Acronym in our world here. We hear a lot about Space Force, the new Space Force, the space domain. How do you see space fitting in and connecting with the other domains, air, land, sea? And I understand that SAIC is one of the Air Force's ABMS, another acronym, awardees. Congratulations, which is the Air Force JADC2. How will SAIC be bringing solutions to bear through the Air Force's efforts?
Okay, so I've kind of been talking about space for space's sake, but we have to remember that space is absolutely essential to warfighters. That's why we put those assets up there to begin with. And so space is absolutely essential to the other warfighting domains for services like weather, GPS, missile warning and missile defense, communications and reconnaissance data. Similarly, the space warfighters, now that they're facing a threat in space, they have to rely on the ground forces, the terrestrial warfighting domains, to help thwart attacks that may be pending on our space systems. So JADC2 is where all those come together to integrate the command and control and to integrate the effects to deny the adversaries their capabilities. And then finally, JADC2 is absolutely essential to reduce latency in our command and control system to respond to high-speed threats like the hypersonic threat. Now, SAIC is very fortunate. We've been picked as one of a handful of companies to get broad awards across the ABMS contract. And we're also one of the few non-OEM companies that are poised to really help the government as an agnostic large systems integrator. So we've got the deep domain expertise in each of the warfighting domains. We've got the core capabilities required to underpin that, such as cloud, software development, data management, and cyber and other things required to facilitate the delivery of those systems. And then finally, we also have strong relationships with strategic technology vendors that we would have to employ to deliver these systems. So by marrying all these elements together, SAIC is committed to delivering the integrated C2 systems required to keep U.S. forces ahead of the fight.
Jim, it's always a great conversation and a quick conversation when it's interesting. So fortunately, we are at the end of our time, but I so appreciate you joining me today and sharing your experience and your current knowledge of space and how it is going to impact and evolve in this new JADC2 concept and future for the military. Thank you so much, and thank you to our audience for tuning in.
Thank you. The pleasure was all mine.
I just want to note that this event would not be possible without the support of our underwriter, SAIC. So thank you to the entire organization as well as Jim. The full webcast has been recorded, and you'll receive a link to watch it in your email later this week. Keep an eye out for it and feel free to pass it along to your colleagues who might have wanted to join us but couldn't be here today. Thanks again, everyone, and we hope you'll join us for the next installment of this webcast series, New Orbit, Space, and an All-Domain Future. Thanks, everyone. Have a great day.